Good morning, my dear students. So today we are going to continue the fourth lesson, particularly about the transition elements. Okay. So in the transition elements are the elements which are present in the D block from group 3 to group 12. So the final electron goes into D orbital. They are called transition because they have their properties transiting from metal to non-metal, electropositive to electronegative, from S block to P block. Therefore, they are being called as transition elements. And already we have discussed about few characteristics. First, their placement in the periodic table, then their electronic configuration. After that, we discussed about their atomic volume and atomic radius, right? And today what we are going to see is about the ionization enthalpy. This already we studied in +1. What is ionization enthalpy? It is the energy that is used to remove the valency electron from a gaseous atom, right? So we have the energy levels. So if the electron is in the fourth orbit, it is easy to remove the electron. If it is in the first orbit, it is difficult to remove the electron. That is the status of the ionization enthalpy. So because what is the reason for that? The electron removal depends upon nuclear charge, right? So in the transition metals, the ionization energy increases. For example, if it is through the 3D series from scandium to zinc, it is increasing, right? It is found to be increasing. What is the reason? Because the nuclear charge is increasing from 21 to 30. Because of the increase in the nuclear charge and the poor shielding of d electrons, and the ionization energy is increasing, but the increase is not very high with lot of difference. They are almost increasing to a very smaller extent only. The reason for that is the crowding of electrons in the D is also leading to repulsion, right? And that is the cause for it. And the ionization energy generally is maximum for zinc because it is having the completely filled orbitals, and therefore removal of electron becomes very difficult. So as far as this ionization enthalpy value is concerned, it is used even to find out the stability of ions. For example, if you take nickel and titanium, their first ionization energy and second ionization energy for nickel is found to be 2490 kilojoules for mole. Whereas that for titanium, it is found to be the first ionization energy and second ionization energy is totally found to be 2655 kilojoule per mole. So when the ionization energy is less, it is more stable. When the ionization energy is high, it is less stable. So using the ionization energy, it is identified that nickel 2+ ions are more stable than titanium 2+ ions. Like that, the first ionization energy and second ionization energy are definitely very useful in deciding the stability of the ions also. So we should know what is ionization energy, how it changes in the 3D series and 4D series, 5D series. In all series, it is found to be increasing only because of the increase in the nuclear charge. And this ionization energy is used to find out the stability of the ions formed by the transition metals. And the next topic, next characteristic that we are taking up is oxidation state, right? So we have studied in detail about this also in +1. So oxidation state is the arbitrary charge that is assigned to a particular atom in a compound when all the atoms are provided with their number of electrons taken and number of electrons given. So oxidation state, we have positive oxidation state and negative oxidation state. So positive indicates the number of electrons given and negative oxidation state indicates the number of electrons taken. So depending upon that, we have positive oxidation state and the negative oxidation state. For example, suppose if we take 3D series. In the 3D series, we have scandium, and after that we have titanium, then vanadium, then chromium, then manganese, after that iron, nickel, cobalt, and after that copper and zinc, right? So these are the elements present in the 3D series. And the first element has got the oxidation state of +3 only, and the last element is also having standard oxidation state. That is, there is a fixed oxidation state. Whereas from titanium to copper, they have variable oxidation state. That means they have more than one oxidation state because they have more possibility of losing electrons in n-1 3D orbital. For example, in this case, it has +2, +3 and +4 oxidation state. This is also having +2, +3, +4, +5 oxidation state. This is also having +2, +3, +4, +5 and +6. This is having +2, +3, +4, +5, +6, +7. This is having +2, +3, +4 and +6. And this is having +2, +3, +4. This is having +2, +3. And this is having +2, +1. And this is only having +2, right? So like that, if you look at the middle, they have more oxidation number of state because in the beginning they have more unpaired electrons in the d orbital. This will have maybe 2, this will have 3, this will have 4, and this will have 5. But again, from iron, it is found to be having more because of the paired electrons. Iron has 1 paired electrons and cobalt has 2 paired electrons, copper has 3 paired electrons, and cobalt has 3 paired electrons, copper has 5 paired electrons. Because of the paired electrons, again the oxidation state is found to be decreasing, right? And this oxidation state stability is being found out with the help of the delta G value using a diagram called Frost diagram. So Frost diagram is the diagram in which a graph is drawn using the oxidation state and delta G value. So if you look at this diagram, right, for titanium and vanadium and chromium, the most possible oxidation state is +3 only. When the delta G value has got more negative sign, it indicates it has got more stable in that particular form. So that is the main application of the Frost diagram, right? So Frost diagram is used to find out the most stable oxidation state of the elements. But so as far as the 4D, 5D are concerned, and OS and osmium and rhodium has got the maximum oxidation state of +8. So highest oxidation part 1, D blocklet, these are the 2 elements which are having the highest oxidation state. But more number of oxidation state is actually found in manganese. So these are the catching points to be recollected as far as the oxidation states are concerned. First, they are variable, and second thing, they have the relationship with delta G value, and the third one, which is having maximum number and which is having highest oxidation state. So this is 5th property. And the 6th property is that we are taking up is standard electrode potential of these elements. Standard electrode potential of these elements. So this is something related to the electrochemical cells, which we will study very detailedly in lesson number 9, right? So this is the potential developed when hydrogen atom is converted into protons, and the EMF that is used in the cell at 1 atmospheric pressure and 298 Kelvin is called the standard electrode potential, right? So when we talk about standard electrode potential this is the one which is used to study in redox reactions. So in the redox reactions, we have reduction and oxidation. There is loss of electron, there is gain of electron. The metal that is oxidized, the transition metal that is oxidized is mostly the reducing agent. And the metal that is reduced in the redox reaction is mostly the oxidizing agent, right? So this is a very important aspect in the transition metals, because one of them will undergo reduction, one of them will undergo the oxidation in this. Therefore, the standard electrode potentials are being used. So higher the standard electrode potential, the stability of the metal is found to be more, and its oxidation possibility is found to be more. So like that, to study this oxidation property and the reduction property in the transition metals, this standard electrode potential values are being used, right? About this we have more study in lesson number 8. So after that we have 3 more characteristics which we will see tomorrow. So this week test we will be writing in silicon tetrachloride, in silicones and silicates, right? These are the 3 topics you will take up a test on Thursday, right? And tomorrow we will continue the rest of the 3 properties. Have a good day. God bless you.